Mm. Can you see the screen?
Yes, we can see this.
Got it. So as you know, Nikhil mentioned that this session. In this session, I'm going to cover like basics, of blockchain, what blockchain is, and what this Web3, technologies are, and how we can basically understand, how exactly these blockchain works under the hood, the basics of these, and how we can use these blockchain to actually solve real world problems which have already been solved or which might not have been solved. So just if basics are clear, I mean, we can build on top of those very easily. So just to start with, why blockchains were actually needed, in the first place. Uh, why things like what things were lacking in the current technologies, like when blockchains were not there. So if we just come to the basics of how society works, or how just any network works. So network, when we talk about the networks, it's actually a group of some entities. They're human networks also, and that entity can be like a human, can be a machine. So if we are in a network, so we together try to achieve a particular thing. We together try to do something fruitful in the whole network, and that means there needs to be some cooperation between all the participants in the network, and there needs to be some incentives for people to become a part of the network, and basically to keep the network going. So and all, like, for a network to actually work right now, without blockchain, what has been happening is, even if there are some networks to to operate, there is actually some sort of centralized single entity that is actually managing the whole network, and that single entity is deciding the fate of the network, and he is that entity is laying down the rules, how a particular network should function. Even in case of a company also, right? You have your managers, and who are uh, and then on top of those, some leadership team that are actually deciding some things. But if we consider a bigger network, maybe a government of a country, there are few peoples, like in the government, deciding certain things. So these sort of points actually leads to where many different problems. Like there is too much dependency on those single entities who are enforcing the rules, who are deciding what needs to be done, what cannot be done. So what blockchain does is, uh, blockchain allows us to run a network without having any centralized entity, without without putting our trust in someone else, to do anything in the network. So what blockchain, like these, and these centralization actually leads to different problems, like uh, corruption, and then monopoly, these kind of things, where some things are not, like, even if you are a part of the network, you are not actually deciding how a network should perform, and how the whole network should grow. Even in the case of Facebook, you use Facebook, uh, you are providing the data, but you are not getting anything out of that data. Even the Facebook is actually monopolizing, like deciding like what you can put, what you can post. Even Facebook has the right to delete your account, right? So even if you are a part of the network, you don't you are not in control, or not, I would not use the word control here, but you are not actually deciding the fate of the network. You are that power is actually in someone else's hands. So this blockchain actually gives us a way to run a network in a decentralized way, and without having any central party to run a network. uh, a network actually can be run by all the participants in a decentralized way. And that and blockchain network actually makes sure that none of the participants of the network is actually behaving in an unintended way. The way the way they were supposed to behave, the network actually decides whether they are behaving as per the network rules or not. And it makes sure that whoever is participating in the network, they are incentivized to keep providing their services to the network in some or other ways. uh, so like in short, like blockchains allows you to run an open network, I would say, that's open to anyone to join, and to govern also without any basically centralized party. So and it's not just the incentivization and keeping an eye on the participants, what they are doing. There are other aspects of the network, like there needs to be security. uh, the whole network needs to be secure. The whatever operations are happening on a blockchain network, that needs to be secured enough for anyone to basically rely on that particular blockchain technology. There are challenges regarding how scalable that network is. I mean, it would not be a very good blockchain network if it's just used by a few people. And if more, let's say millions of people tomorrow want to join the network, then that network cannot perform. So these technical challenges are there, which needs to be taken care of before we can say that this is a secure, scalable, reliable network that we can use to perform our maybe day-to-day operations or any financial operations. So these are the things which we need to make sure whenever we are talking about any decentralized network. So and like I talked about the incentives model also. So I mean, since it's an open network, there is no central entity or a person you can actually go to if some things goes wrong. So that's you can consider as a downside of a open decentralized network, that there is no person to reach out to for any support if anything goes down in the network. But that's the beauty of a blockchain and open network, that they never goes down just because they are distributed. uh, there is no single dependency on any single machine, for example. So even if one or two participants in a blockchain network goes down, it doesn't make the whole blockchain goes down. And that's what power the availability of the blockchain network. And whoever is participating in the network, they needs to be incentivized. Otherwise, what's in it for them to keep providing their services to the network. So usually what blockchain does is it incentivizes people who are becoming a part of the network, providing their services. They are incentivized in tokens, what we call tokens. So tokens is nothing but a digital currency, you can say, that stays basically on these blockchain networks, and whose value is actually defined by the society, or the people who are actually using the network. uh, if people consider a particular token valuable, then they will the value associated with that token will automatically increase. So it's all about how you value a certain thing. It's just as simple as that. And these tokens are actually digital currencies. There is no physical elements to these tokens. They all stays on chain as a digital content. uh, so yeah, that. And if I just go a bit more technical, like what a blockchain is, if you are wondering about, uh like if we want to like imagine how a blockchain is running. So imagine there are multiple servers running on some machine. Even even today some blockchains are very light that you can actually run those nodes in your local machine also. So imagine there are different nodes. Uh, they might be running on AWS, they might be running on any other cloud provider, they might be running even in your local, system, laptop, or desktop. And imagine they all are running a same piece of code, and in that piece of code, like everyone is running same piece of code, and it's written in the piece of code that how they should interact with each other, how they should put information, more information in the system, and then how they keep growing those information, and how they can actually define certain set of rules. So rules is nothing but some lines of code that the blockchain those that blockchain developer has written, and that piece of code is actually running on multiple machines, and that all machines are distributed across the globe, and they all are connected to each other. And even if some node is not directly connecting to all of the nodes, but let's say one node is connected to 2 3 4, and then third is connected to 5 7 8. So these like uh, this way, eventually you are actually connected to the whole network.
Sachin, I guess you got muted by mistake.
Okay, can you hear me now?
Yeah,
Yeah,
yeah.
Sachin, that's perfectly fine. Please go ahead.
Okay, what part did you miss?
I think
Like,
we got everything that you wanted to say.
got it. So yeah, as I was mentioning, this is how you can imagine how a blockchain is running. Just a bunch of nodes connected with each other, passing messages between each other, and the piece of code that is running in these nodes, those are defining the rules, like how a blockchain, uh, for example, what kind of transactions that blockchain network can actually process, and based on the transaction processing, what outcome is there. Uh, how a token balance needs to be updated. So those different kind of rules are just written in that node, and that multiple people are running the node, and they are getting incentivized, like the information which they are passing, it's all about that information eventually. And each node has some state that every node connected in the network considers to be true. So if everyone in the node has the same state, then it's considered to be true, and then we can move on to other states. They will pass different messages, states are going to change, and the new state will become new state of the whole blockchain. And whatever is written in that new state, it has to be considered truth, because everyone in the network is saying that. So this is how you can basically imagine how a blockchain performs in a very simple way. And now, let's talk about these concepts, like what is Web 2, what is Web 3, what is Web 1. Uh, so if we just talk about Web 1, so those are early internet times, when on the internet there were only static pages, read only websites. You can just put information and people can just read it on the internet. That those kind of technologies comes under Web 1. And then Web 2 came, which was more interactive, where instead of just reading a website, you can actually interact with it. You pass your in messages, you exchange messages between different people over the internet, messages are being passed. So this all comes under Web 2. Like everything you see on the internet apart from blockchain, uh, all comes under Web 2. Facebook, Twitter, any Google, even Google. So all these platforms, they are running on Web 2 technologies. Uh, mm, Usually Web 2 technologies comprises of a front end, some back end servers, running some database connected to it. So usually, like, these are the tech stacks you can consider a Web 2 tech stack, which current internet applications are being run on. Now Web 3 is the next version of, you can say everything that is based on a distributed technology, or more I would say decentralized technology. where there is no single governing entity, governing the rules of that distributed network. Those technologies comes under Web3. So blockchain is one part of Web3, because blockchain is decentralized, blockchain is distributed, but blockchain itself has its own limitations, I would say, in terms of data storage. For example, you cannot just put all the data you have currently on web 2 to the blockchains. That's not how even blockchains are not that much capable of storing that much data, I would say. So for example, for the storage purpose, we have decentralized storage networks. We have Filecoin, we have IPFS. Those networks are again decentralized, those networks are distributed, but their main purpose is to actually store a lot of data. So that comes under Web3. So anything that's decentralized, distributed, and there is no single entity, it's all self-governing and trustless. You are not trusting any single party to run the whole network. All those technologies comes under Web3. And this, like, Web3 is going to be like the future, going forward. Even I'm not sure if you followed, like, Facebook recently rebranded to Meta yesterday. So they are also moving to future directions. I mean, they have not disclosed any much information on what this means for Facebook, but they are definitely exploring the future technologies. There is a thing called metaverse. Maybe someone might be linking that to those metaverses. But yeah, the thing is, it's a fact that things are moving on, technologies are being upgraded, and we are actually shifting from a web 2 to a web 3 space, actually, that's more decentralized, self-governing, and trustless. uh, Now let's talk about decentralized applications. So far we have covered what a blockchain is, how we can actually imagine how a blockchain network is performing, is actually running. Bunch of different nodes connected to each other, passing messages and updating their states, individual states. That's what we call a blockchain. Now we need to build, that's the base infrastructure. So you can consider it like you can compare it to the internet. So in order to build an application like Facebook, you need internet, right? In order to connect your users to Facebook servers, connect the Facebook interface to multiple databases which Facebook is running, so you need internet. Now, in order to build decentralized application, you need blockchains. So those are considered as a base network on which these decentralized application will be running. Now, if we compare it to a traditional application, not decentralized application, but just normal apps. So a basic simple web 2 app, again, as I earlier said, would comprise of front end, a back end, a database, and I mean, you can put different scalable databases, or maybe a cluster of database. Those are, you can do a lot of things, but yeah, the basic thing is you have a database, you have a backend server, you have a front end. Front end is connected to the back end and it's saving the data in the database, and front end is saving and reading the data from the database. But there is always one single entity who is running those servers, who is in control of what the data is stored in the database. But in the dApps, it's a bit different. So you can replace the whole database part with the blockchain, uh, with the blockchain data, basically. So you don't need to host specific database in order for your decentralized application to run. You can just consider whatever the blockchain is storing, you can just start storing more of your data into the blockchain, and that will act as your database. Front end will definitely be there, but you can actually get away with the back end altogether. Even a decentralized application can just run on single front end, and no servers you have to run. Just once, even for hosting for this front end, you don't need to run a server. You can actually host this front end on decentralized storage network like IPFS, and other such kind of network. So you literally have all the infrastructure available, open to everyone, open to use. You just have to build your application, host it on these network, and your application will be up and running, right? But usually, as I earlier mentioned, you cannot just store all the data to the blockchain. So so usually, people store that data to the blockchain that has uh, a sense of ownership, so that we can not we can actually make the ownership on the blockchain. So it's there is no control for the application developer to, for example, say that this is not your uh, this is not the item you have purchased, or maybe you can change those things in the backend. No, that's not a smart contract developer, a decentralized application developer can do. So just a blockchain and a front end, there can be a decentralized application. But usually in an application you need to store some more data, not just apart from just storing the basic ownership information and those things. You sometimes you need to store images, sometimes a huge chunk of text maybe. So those metadata, I would say, you can actually keep on a backend server. But again, the main things like if you own some data in that platform, that stays on blockchain, and which cannot be like controlled by the application developer itself. uh, so these are the things using which we can run an application on blockchain. And when I say you can actually save data on you know blockchain, so like storing part is done, but what about the business logic you have in your application? Usually we run these business logic on our backend servers. Now where we will run these logic? So there are these things called smart contracts. Smart contracts again are just a file with some lines of code in it, and on that smart contract you can actually write your business logic. The language usually is Solidity, but there are blockchains that support other languages for writing these smart contract also. So if you want to write a program that runs on blockchain, just to start with, you can learn Solidity, and you can write that file, uh, that Solidity file with that programming syntaxes. And you can even just write a simple addition program, for example. You just write a function, there are constructors, function, there's a file, compile it, deploy it on the blockchain, and there you go, you have your business logic running on the blockchain. And then you can interact with your smart contract by creating a front end. And it's similar to how you connect a front end to a backend server. You can, in a same way, you can actually connect a front end to a blockchain. So when you are connecting a front end to the blockchain, it's not like you are connecting with all the nodes that are in the blockchain. Just a single node is enough, because each node in the blockchain has the same data. So it does not matter to which node you are connected. uh, Choose any one of the nodes, connect your front end to that, and you are actually connected with the whole blockchain. And you can now just send transactions to that node. That node will actually broadcast your transaction to the whole network. And your transaction, if it's valid transaction on that blockchain, it will be reflected in the whole blockchain. And the whole world who is actually connected to the same blockchain from across the globe, they will see your transaction on the chain. The state will be updated, and everyone will see an updated state of the whole on the whole blockchain. So that's how you can actually connect your application to a chain. You can actually build your business logic by writing smart contracts. And blockchain can actually act as the storage layer for you for these decentralized application. uh, Now one more thing is left. when you're building an application. So just for the just to make sure, okay, you can hear me, right? There is no disconnection this time.
Yes, you are audible, sir.
Good.
Yes, sir.
Yeah, I'll keep on asking, uh, just for the sake of safety. Okay, where I was, yeah, the last part of making a blockchain application. So consider, again, let's take an analogy of Facebook. When you interact with the Facebook, you create an account. uh, you have your identity as as a username, the Facebook username or email ID. That's your identity on the whole Facebook network. And you can actually log in with that ID and password, and whatever operations you do, then it will be connected to your account, and the people can see you have actually post something or like some post, something like that. Similarly, you need an identity on blockchain, because if you are doing something on blockchain, people needs to know that who has done this operation, who is the owner of this transaction, who has sent this transaction. So in blockchain, there is your identity is called an address, a blockchain address for you. And the good thing is, you do not need to register anywhere to get your address on the blockchain. It's all cryptography. You can basically, it's a public and private key pair. You can choose any cryptographic library, generate a random public and private key pair, and that actually can be your identity on the blockchain. You don't even need to be connected to the blockchain to generate your identity. Just download one cryptographic library that support public and private key generation, using some random seed. Just generate that. Keep that private key safe, because uh, you can consider it as your password equivalent of on the Facebook platform. So just like on the Facebook you have password, on the blockchain you have these private keys that act as as your password. And whatever operations you are doing with that private key, that will be associated to your public key. So public address is a 20 bytes long hexadecimal string. That is actually your identity on the blockchain, and whatever transactions you do from that address will be reflected on the chain. And whatever ownership transfer happens in that transaction, that will be reflected to your address, based on the business logic you have written on the smart contract. So to uh, to manage these addresses, to manage your private keys, to manage your identity, we have applications called wallets, Web3 wallets. So these are the applications that actually makes it easy for you to manage your public and private keys, basically. I'll show you also on my browser. You can see this application, this extension called MetaMask. So this is actually a wallet, and it is actually managing my private and public keys. And if you see, this is my account, and this address which you see is my identity on on the connected blockchain, for example. And there are actually different blockchains you can actually get connected to. So all you need is a wallet, which can handle your public and private keys. And this wallet can be connected to any blockchain application. And then once it's connected, you can just start sending transactions to the blockchain. And blockchain state will update, your transaction will be processed, and whatever you're trying to put on the blockchain, that will be reflected. So that's how transactions actually work. That's how you can actually interact with the blockchain based applications. Now what we can actually build on blockchain, you can build any kind of application, literally. uh, Even today, if you see, there are prediction market applications. There are games that are being built on these blockchains. uh, there are this DeFi, is decentralized finance. So all the financial applications, exchanges, lending, borrowing platform, you can actually build on blockchains, and everything will be decentralized. No one will control what you own on a blockchain. So if you own some tokens on a chain, so when I say you own tokens, that means those tokens are associated with your address, and you can actually find a state in the latest, basically in the latest state of the blockchain. There will be a piece of code that says that this much amount of token belongs to this address, and if you have the private key of that address, that means you owns the token. You can actually do anything with those token, transfer it to any other people. That's how the ownership on the blockchain is decided. Whatever the latest state of the blockchain says, that will be considered as the final truth. And if the latest state says you have this much tokens, then you actually have those tokens on the blockchain. So everything is digital. Everything is decided by piece of code, no human interaction at all. uh, and that's how blockchain is actually running. If we go further back in the history, like how different blockchains evolved. uh, so you all must have heard about Bitcoin. That was the first public blockchain that became very popular. And after that, that concept of blockchain evolved, and more blockchains came, and the whole ecosystem, the whole space got better and better. So uh, initially, even before the Bitcoin, like the whole blockchain is based on the concept of cryptography. And even before Bitcoin, there was this system called Hashcash, which was trying to solve the email spamming, using cryptography and incentivization. I will not go much deeper into it, but just for your knowledge, there was this Hashcash system which was uh, actually mentioned in the Bitcoin white paper. So then with Bitcoin came. Bitcoin only was doing the transfer of digital currencies, and that's what Bitcoin does. And that digital currency is itself is a Bitcoin. So Bitcoin is a blockchain also. Its currency is also called Bitcoin. So Bitcoin was the first blockchain where you can actually transfer digital currencies without depending on any single entity in the whole world. It was self-running chain. First block on that blockchain was mined on 9th January, and then 50 BTC was rewarded. So earlier I mentioned, if you are a participant in the network, you are actually rewarded by the network for your contribution. And those rewards are actually the token, digital currencies. And if you see, that time in 2009, there was like literally no value of this BTC. And today we see like BTC is like more than $60,000 one BTC. But like how this value accrued over these years, it's just simple. Like more and more people attached value to this coin. The more and more people think that okay, BTC is valuable, then they are ready to give, let's say, $1,000 for one BTC. And then that people thought that no, it's worth $2,000. So that's how the value of the BTC grew over time. And today it's like more than one BTC is like more than $60,000. uh, and the person who initially mined this block, and now you must have imagined like how much money that person has actually made. So again, like for him, it's actually a reward. He provided his services to the Bitcoin network that time, and he was rewarded. And now the value is increased, now he is happy. And that person who actually came out with this concept called Satoshi Nakamoto, he was the creator of Bitcoin blockchain. And then since Bitcoin was just doing the money transfer only, digital currency transfer, nothing else, then Ethereum blockchain came. The Vitalik Buterin is the creator of Ethereum blockchain. Now on Ethereum, again, you can also transfer digital currency. of Ethereum called Ether, but it also introduced concept of smart contracts so that you can write your business logic on these blockchains. And literally you can write any business logic, using smart contracts. And then, but again, the problem was it was not scalable. uh, it was very costly to use these blockchains. Then layer 2 blockchain, came. They actually claimed to be a scalable blockchains. uh, with different technology, they are running the blockchain just to make it scalable, cost effective. And that's how the whole ecosystem is growing. uh, whatever problems previous blockchains were having, those are being solved, new blockchains are coming. So the whole system is actually growing and solving problems one by one. uh, I have like told you like how a blockchain works, but maybe we can just quickly take an example of one transaction. uh, you know like how that transaction is actually executed and validated and reflected on the chain. So let's take an example. On the blockchain, let's say a there are two persons, A and B. A has some tokens in his account. uh, A wants to send those tokens to B's account. So again, when I say account, it's like a public key. And A has its own private key, B has its own private key, but the public key are public. Like A knows the public key of B, B knows the public key of A. So you can just send money to any public key, in the network. So, let's say A wants to send money to B, the transaction, A will actually do a transaction, on the blockchain. It will send the transaction, it will create a transaction, it will sign that, cryptographically sign the transaction using his private key. And then the transaction, that signed, piece of message will go to the any one of the connected node in the blockchain network. Now, what that node will do is it will take the transaction, it will validate whether it's in correct format, all the parameters are valid. It will see that the signature is valid, and then once everything checks out, uh, it will update the state of the blockchain and broadcast that information to all the nodes connected in the network. So just when we just so there's a concept called block. Block is nothing but a collection of transaction in a chain, and we just categorize them in a block, and then we say like, okay, this uh, block of transactions is processed, everything is validated, let's run them and update the state of the blockchain. So each transaction is actually run in one order, and the business logic is executed, and the state is changed. So once all the transactions are executed, we can say that a block is mined, uh, and whatever state transition it was supposed to do, like each transaction, and the order is actually really important. So in a particular order only transactions will execute, and the state will change on one node initially, and that node will actually broadcast its state to all the nodes in the network, and every other node will actually verify whether it's a valid state change or not. If it's valid state change, everything checks out, all the other nodes in the network will update their own state, and that's how a new state will be formed. A block of transaction will be mined, and when you say mined, that means again state is changed. And in the transaction which A sent to B, it was written that this much amount of tokens needs to be transferred from this address to this address. So that business logic will be executed once a block is mined. uh, and then the block is actually broadcasted, everyone update their state. And now if you just read the state of the blockchain and ask what is the balance of B, now the balance of B must have been updated because the transaction which A sent was successfully executed on the blockchain. And that's how you send money. So you send tokens on the blockchain from A to B, and literally you can write any business logic in your transaction. So it's not just a token balance update transaction, you can do multiple updates in a single transaction, multiple storage, multiple state updates. So though that's how basically a blockchain transaction will actually work. And and it's interesting that how multiple nodes are connected to each other, but at the end of the day they are actually reaching a common state. Everyone is saying that, everyone is saying the same thing, and that's what make blockchains uh, more available. There cannot be any downtime. Everyone is saying the same thing. Even if one node goes down, you can ask other node, what's the current state of the blockchain. And and this actually takes care of this double spending problem also. So just to tell you what a double spending problem is, let's say if I have some money, I give to A and B. uh, it will not be the case that A and B both will have the tokens which I have, and I will like my balance is deducted, but it will not be the case that both A and B balance are updated with the same number of tokens. So I just send to A, B will not get those. If I just send to B, A will not get those. Even if I send two transactions, and I just have, let's say, only 10 token. I send a transaction saying that I want to transfer 10 tokens to A, and then before that transaction is actually confirmed, I send another transaction, because the state is not yet updated, right? I still have those 10 tokens. So I just send out another transaction and saying that I want to now send these 10 tokens to B. So either A will get it or B will get it. Like both will not get it. Either of those transaction has to fail on the blockchain, and that's what blockchain makes sure that you are not double spending your money. uh, Features I have, like I'll reiterate these features of blockchain. Distributed means many people are running the nodes in different regions of across the globe. It is actually distributed. Immutable, in a way that once a transaction is done, once the state is changed, you cannot roll back the state on the blockchain. And that's what makes it immutable. Peer-to-peer network, again, like there are multiple peers or nodes, they are communicating with each other. Tamper proof, uh, blockchain is based on cryptography. So again, like cryptographic enabled. So based on cryptography, it is making sure that it's tamper proof. You cannot change uh, any data in a transaction. If I have sent one transaction, and if I says that you only A to B, money needs to be transferred, then no one in the world can actually change that information. That's how it's tamper proof. uh, just for the sake of time, I'll just go quickly here. uh, there are multiple type of blockchains: public, private. Public is open to everyone. Anyone can be a part of the network. Anyone can run the node. uh, Private are not such case. You can actually I mean, blockchain again is just a piece of code. Whatever you will write in that code, that's how the blockchain is going to perform. In private blockchain, you just put restrictions in the code that not anyone can join the network, not anyone can become a node in the network. And that's what makes them public. Like few people are deciding who can actually join the network. Usually, public blockchains are slower, private ones are faster because of less participation and more restricted rules. Security, public blockchains are more secure than private blockchains. Uh, and because I mean, in private, you might have some control over the chain. I mean, that the way you write the code, the way it will perform. Identity in private blockchain is, they might put KYC, for example. on the blockchain. But in public, there is no KYC. You just download a cryptographic library, generate public private key pair, and that's your identity. No one will be able to know that those public private key belongs to, for example, my PAN number or Aadhaar card number, for example. So that's how it's anonymous. Smart contract, I have already told you about. How to use blockchain, I have told you. You need a wallet, uh, you need a connection to one of the node in the blockchain network. You need an account, that's your public private key pair. Wallet will manage that for you. Now the main thing is, when you send a transaction to a blockchain, you are actually signing some piece of code. uh, but in order to write anything on the blockchain, you need to pay a transaction fees. And usually the transaction fees are in the native currency of the blockchain. So if you are if you want to write something on the Ethereum blockchain, you need to have Ether in your wallet, and that's what called the transaction fee. And there are other complexity involved when you are sending a blockchain transaction. Normal people would not be able to interact with the blockchain, if they don't know about gas prices, if they don't know what the price of the currency is, if they don't know how to get those currency in their wallets. It's not possible, it's not easy for them to use blockchain. That's what making blockchain less usable. That's why we are not seeing adoption of this technology by masses. I mean, not everyone is technical in the world, right? uh, Even even the users who are using Facebook, they don't know a thing about what's going on behind Facebook, how it's running. I like, ideally that's the stage we want to reach with the blockchains also. So normal people using some application built on blockchain don't need to know how blockchain works. They should be able to just interact with those applications, and there should not be any complexity behind using a blockchain based application. uh, and that's what actually Biconomy does. So Biconomy is actually aiming to simplify the whole blockchain experience by providing APIs and SDK to the blockchain developers, so that when a transaction comes, so there's a tap, there's a blockchain, you can directly send the transaction, pay the transaction fee, or there is a Biconomy in between. Instead of sending directly to the blockchain, you can just send to Biconomy will send to the blockchain. And of course, the Biconomy infrastructure is connected to the the DApp, the application. So the application developer will actually take care of paying your transaction fees. And and Biconomy will take care of dealing with all the technical complexities a blockchain transaction has. Like, you don't need to know about gas price, you don't need to worry about whether your transaction will be stuck on the blockchain or not. Biconomy is actually taking care of that. And when it comes to paying transaction fees, the application developer is actually paying those fees on behalf of their end users. uh, so I mean, consider it like, if you're watching Netflix, every time Netflix asks you to pay to watch a video, that would not be a very good user experience. The user just pay a monthly balance to Netflix, and Netflix is actually paying the cost of AWS servers, right? They are not charging those costs for you for each video. That's not how application should perform. And that's what we are trying to achieve. Like, interacting with blockchain applications should be that easy. And that we have uh, different products that actually make this possible today, using our SDKs and libraries. You can actually explore more once you get to know about how to make blockchain applications. So I would not say just straight away look into Biconomy. Just first initially learn how to build blockchain based application, learn how blockchain works, make simple application, write some smart contracts, make simple UIs, get them connected to your smart contract, learn how to deploy those smart contracts, and There are different tutorials for doing that. And then once you are there, now then you will be facing these problems, that if you are building an application for your user should not face much friction while using your application. And that's where you will be using Biconomy tomorrow to build your blockchain based application. So yeah, that's it from my side. I would not stretch it too much. I hope I have covered all the basic things. uh, over to you, Ritesh.
Yeah, so I think guys, you can raise your hand and you can ask a question one by one.
Uh,
Yes, Vedansh,
may I
please
ask?
go ahead.
So, Sachin sir, it's a question to you. Like you said about the blockchain technology and all, and so Bitcoin is majorly based on the blockchain technology. So, with regard to the Bitcoin, if I see to the current scenario of our government of India, the government of India has put a bill and as well as an ordinance in the past to ban the Bitcoin as well as the blockchain technology. And the money laundering activities can also be done through the blockchain technology as well. And the e-waste that is being currently generated to mine the bitcoins is also a lot. So do you think that the it would be beneficial to a country such as India?
So again, like Bitcoin is not just the only blockchain or not just the only technology, distributed and decentralized technology. Bitcoin actually, paved a path that showed the world that this kind of technology actually can work. You can actually build these decentralized network that are self-running, operating without any, a central entity. Now the banning of Bitcoin, which you are saying, uh, I mean, what central government can do is, stopping your bank accounts from dealing with these, blockchain related application. They cannot stop the Bitcoin blockchain, because the good part of the, Bitcoin blockchain is there is no central entity where the government of India can just go to and just stop their operations and, bring the Bitcoin blockchain down. That's not how it works. What Indian government has is they have the power on Indian rules, like Indian law. They can make some laws, that you cannot interact with a blockchain based application or this and that. But I don't think like that's practical to go with. This this is a technology, and it's not just about money transfer. It's about having a system where you have the ownership of your asset without actually depending on any third party. So I mean, government of India can take any actions. They can actually, I mean, even they ban, uh, stop. They told RBI that any account uh, activity related to cryptocurrency should be banned, and I think they might have banned some accounts, but that's not I would say a long term approach to go with. Even the finance minister said that they are actually looking forward to adopt this technology, not Bitcoin I would say, but the technology we are talking about. So it's about what actually can be built using this technology, how we can reduce the dependency on third party systems or any central entity in any system, how we can reduce corruption using this technology. These types of use cases basically we need to think about, and not just restricting ourselves to Bitcoin blockchain, or how costly one Bitcoin is. That's just one aspect of blockchain and decentralized technologies.
Sir, I totally agree that the blockchain technology is being used in other aspects as well. But sir, you didn't address about the e-waste as well as the money laundering activities. And sir, many of the apps that are using blockchain technology in the current scenario are basically on the bitcoins and Ethereum and all the coins that digitally transactions. And sir, I feel that your app itself is based on this only. So can you elaborate on more?
Yeah. So the money laundering activity which you have mentioned, I mean, if you see, it's very easy to track these transactions because Bitcoin is an open system. Everything is transparent. It's even more easy to track these kind of transaction on a public blockchain rather than just tracking in a centralized system where you don't have access to the data, you don't have transparencies in those systems. And there are actually some companies who are actually working on this problem, where we can actually track some transactions if we wanted to, and connect the dots, like from which IP address the transaction came from, and those things. I mean, there are cyber branches that are dealing with this scenario, and blockchain is actually making it easy for them to track these kind of transactions. So again, a technology should not be restricted based on the how it's actually misused. But again, every technology can be misused, to be honest. Even blockchain was not there, there were still these activities going on. But on the positive side, if you do these money laundering activities on blockchain, everything is public, everything is transparent. It's even become more easier to basically track, if if you want to basically track down a particular transactions. So on the contrary, it has transparency, it has availability. That's what makes it more easy to track down these transactions and take proper actions based on that. So again, like, every country is coming out with their own regulations also. So you can actually define that if some money laundering activity is found on a blockchain, you will be punished, for example, as per our country's law, right? These, I think these kind of regulations should be there. But like banning the whole blockchain or technology, I don't think it is a good way to go forward.
Right. Thank you, Sachin, for that answer. Guys, any other question? Unmute kar lo yaar. You can unmute yourself and ask any question if you have. Actually, I have some questions, Sachin. So very first question would be this: that when you say or look at the bitcoins, there's so many bitcoins. So initially you had one bitcoin, जिसके बारे में no one was interested to talk. Then it boomed, and everyone is now talking about Bitcoin. And then series में you have so many new bitcoins: Ethereum, Cardano, Solana, right? And what do you think about Bitcoin in terms of that? Will it gonna be eventually a asset or used as a currency? Because now the perception is more like it's gonna be more like an asset, like a gold. So do you think there gonna be a time that government, the mainstream government, which in general forces us to use their currencies, will there gonna be any possibility that the Bitcoin gonna be the mainstream transaction for every purchase we make as a consumer in future?
I mean, I think it should not be like this. The Bitcoin should not be considered as a official currency of particular country or anything like that. Uh, I mean, Bitcoin, even the way it is more costly. I mean, you compared it to gold, right? The gold, the prices, like, no one has control over the prices. If the whole community, whole the people who are dealing with the Bitcoin, they are saying that now this is highly valuable, the prices will go up. When they start seeing that now Bitcoin is not that valuable, of course, like, automatically its value will go down. So I mean, it's all about like what you want to accept as a payment mode, or any exchange of basically services. Uh, if a government wants to accept Bitcoin as a official mode of payment, they can do that. But I think it's people will be like coming out with their own digital currencies, especially these governments, because they usually don't want to give the control which they have. But eventually, since the world is moving towards a digital world, uh, it's possible that even India tomorrow comes up with their own digital currencies. And the way we are dealing with these uh, you know uh, hard currencies, the coins, physical coins, that might go away tomorrow. It can happen. I mean, I think people are using Paytm, they are digitally transferring money, but eventually it's all under the control of RBI, right? It's not a public,
Right. Got
your digital currencies are even not in your control. If RBI bans your account, the whole digital currency. So it's about the ownership. If RBI says you hold 10 rupees, then you hold 10 rupees. If they say you don't hold, then you don't hold. But if on a blockchain, blockchain is saying you hold 10 tokens, then forever you hold that 10 tokens, and no one can actually take those tokens away from you unless they get your private key. That's where you need to be more secure, with your private key. uh, so it's all about the
Right.
ownership, of the assets.
Short,
Sir?
very short follow. Vedant, just a second. Very short follow-up question on this. Are you aware about Pi network?
Sorry.
Pi network. There's a coin called Pi coin.
No.
Right. Just to give you the context, basically, there's Stanford graduates actually created this platform where they have introduced new coin which is PyCon basically, and they have made the mining so easy that the way in general any user or the any person who owns PyCon mines is basically they click on mining button each and day, and they share that link to their friends, and they try to build this in a way that more people come to the platform, more people join the platform, more and more people see that PyCoin is valuable, and then it might happen that one day that's gonna be like one of those coins like Bitcoin, Ethereum. So what do you think if the concept like these if come in the market when they say it's very easy for you to mine any coin like just clicking on a button every day? So do you think that there's gonna be possibility of there gonna be so many coins in the market, and then in general we will have to stick to one or two coin on only?
Yes. I mean, there even today there are like thousands of tokens on Ethereum blockchain, but not every token is valuable. Most of the tokens are just for the sake of generating the token, because it's
Yeah.
very easy to deploy an ERC20 contract on Ethereum, and you can just call that a token. And
Mm-hmm.
but but there has to be some value associated to a token. Uh, and that value has to be associated with the actions which we are performing with a particular blockchain or any other technology. And if the people think that the operations which they are doing associated to that particular token are valuable to them, then of course that token's value will increase, and more people will start using those token. But yeah, again, I would not see that there can be like thousands of valuable tokens in the system. There will only be few of them that are more valuable, and more people will actually adopt those tokens rather than creating again their own set of tokens.
Got it. Vedant, please go ahead.
Sir, as you said, if like I'm supposing if government of India announces its own cryptocurrency, so do you think like the cryptocurrency can act as a fiat money in our country
uh, it can. So
in the
there.
future generation? Like,
Yeah. I mean, the way you are basically generating a token on a blockchain. uh, if you are connecting that with fiat money, then that country's regulation comes into play, whether you can actually whether you can actually associate that digital currency on the blockchain with the actual fiat money the people are using. So it's up again, if the regulations comes into play, it's up to the decision of Indian government whether they want to back that digital currency with the fiat supply which they have in the RBI. So it's up to their decision. It's possible because there is one currency on the Ethereum blockchain called USDC that is actually backed by the actual United States dollars. They have they claim to have that much amount of reserve, that the amount of supply which USDC token have on Ethereum blockchain. So uh, when we say it is backed by fiat, you mean like that price of that token is actually the same as the fiat price. If we are saying that 1 rupee is like 1 INR, then one token is value is equivalent to 1 INR. So for that to happen, to maintain its value, uh, if you are choosing INR, then there has to be some regulations over there, and Indian government actually have to come into play to decide whether they can actually allow that reserve to be valid as like compared to the total supply of that token on the Ethereum blockchain. So it's possible. I mean, if the Indian government wants to, they can.
Oh, thank you so much, Sachin. So we're gonna take the last question. If any one of you have any questions, so please unmute.
Hello,
Okay,
sir.
cool. Yeah,
Am I aud-
please go ahead.
am I
Yeah,
audible? Hello,
yeah, go on.
sir.
Yes, you are.
Sir, talking about deploying smart co- contracts on the Ethereum blockchain, what UI frameworks should one learn?
So if you want to deploy on it, like of course you will start with the test networks where you would not need to hold the actual ether, but the
Yes.
test ether. You can check out Hardhat framework that actually helps you to deploy Hardhat. So it's a framework to help you deploy these smart contracts on any blockchain, any connected blockchain. So usually I would suggest you start with the Ethereum test networks. There are multiple test networks: Kovan network, Goerli, Rinkeby network. So choose any one of them. I would say choose Kovan. You can easily get test tokens of Kovan network, and then start with that. And write smart contracts, deploy on Kovan test network using Hardhat, and then just experiment around with those. So basic libraries, if you are asking, Hardhat is the one for deploying. Solidity language you should learn for writing the smart contracts, uh, and Ethers JS library for making the for connecting the front end to the blockchain test networks or even main network. So these three are the basic libraries you can start with.
Uh, Thank you.
Any any other question, guys?
Hello, sir.
Hello.
I'm audible.
Yeah.
Sir, I just want to ask, I'm just entered in my first year of my college and I am new to programming. Means I'm learning C language. If
Mhm.
I want to become a blockchain developer, so how I should begin and how I should start? Whatever I found on internet, it's showing that you should learn Solidity language. So, but I'm not confident that if I will start Solidity learning now, whether I can, whether I will able to means get it right, or I should first learn basic languages such as Java, C++, then I should shift to Solidity. Means is there any roadmap for blockchain development?
Yeah. So
Please explain.
yeah. Don't directly start with Solidity if you are new to programming. Just start with basic languages like JavaScript, C++. If you're already running, that's even good. That's even better. But just for the sake of simplicity, JavaScript is the most simple programming language you can just start with. uh, and writing smart contracts is not a rocket science. If you are a good programmer, you can write smart contracts. It's just about learning the syntax of Solidity. How what syntax you want to use if you want to create a function. Business logic is the same, in Solidity also. So if you are good programmer, you can write smart contract. But usually, the what makes it difficult to write smart contract is the efficiency of the code, because you do not have infinite storage in smart contracts. So you have to be very careful about how efficiently you are writing the code, how you are able to achieve a certain business logic in less lines of code. That's what makes Solidity hard to write. But general programming you should learn first. Go with JavaScript, I would say. Once you have basic programming skills, then switch to Solidity, learn its syntax, learn how data is stored in the blockchain, and then you can just start writing smart contracts.
Thank you, sir.
I think we won't be able to take more questions, so it's time. Sachin, thank you so much for your insights. Clearly, we all can see you have a really good hold on the subject, and I'm pretty sure you're gonna have a great tenure ahead with your venture. So all the best for that, and yep, thank
Thank
you.
you.
All
Thank
right.
you.
Just a small thing before we head out of the meet. The recording for the meeting, as well as other resources from Bioeconomy, would be available to you on your emails shortly. Also, the link to your Telegram channel where you can get updates to this, all the activities that Bioeconomy conducts on a regular basis. You can join the Telegram channel to get updated for that. Thank you, everyone.
Yep.
Yeah.
Thank you guys. Bye. Good
Thank you
night.
guys. Thank you. Bye bye.